very large database. So first time when Dr. E.F. Cole proposed such a relational database model to address the problem of the size of the data. When we have huge amount of data, the traditional way doesn't work very well. So it was proposed that so IBM support such a relational database model? Actually not. So IBM has hierarchical database. It's called I35 and also it has the DB2 and so they have, IBM already had their own DBMS system. So they almost ignore such a new database model. So they don't like the IBM decision. So some of the researchers, including Dr. E.F. Cole, they quit the job, then make the company and develop. Then finally they announced the first commercial relational database management system. It's a version 6. By what? Which company? That is Oracle. That is an Oracle company, actually Oracle company from the IBM, the research. So then at the time, that is the 1980, middle of the 1980s. So actually I learned the Oracle database from the 6 point something, but still we have, right now we have the Oracle 12 something. It's not much different.
How come?
So whatever, CI, whatever, actually Oracle 6, Oracle 12, it's not much, 90% are the same. Because that we will learn throughout the semester. Why? Because it's already standardized at the time. So that is the rough history of the DBMS system. Any question in chapter 1 and chapter 2? There are a lot of story that we can discuss, but I'm going to skip some part. Yes?
So he said the database users is not that important.
Oh no, important. Yeah, but so they using so when we manage the data, so we will see whether using the database is the best solution. We will say no. Sometimes yes, sometimes not. So when you get a job, so for example, you are hired as a database administrator or something manager of the database, so your boss will ask you, so this time we need to build a new database system to manage the customer, then please propose any idea. At that time you need to decide whether we are going to use a database, okay, or just a file system. Okay? Not always using database is better than file system. Then why don't you use the DBMS on your laptop? Right? Nobody uses the DBMS system to manage your file, right? Your information. So we will see. Okay. So we already talked about what is the model. Model is just a thing. It's a data structure. Okay. Because anyway, we are using the computer. This database will be running on top of operating system computer, which means it should be structured. Okay. Also, not only just such a simple data structure, but also it should keep something meaning. Because when we define the data, what is the data? It's a meaningful information. We need to keep such a meaning. Okay. That is sometimes the relationship, okay, over system. And also, not only just the structure, the concept of such a structure, but also we need to define such an operation. Operation means we should be able to access the data. We should be able to modify the data. We should be able to manipulate the data. So such a manipulation, such an operation should be defined. That is the database model. Like for example, in hierarchical database model, get next, get unique, and something that is the operation. And also, such a concept will be defined as constraint. What is a constraint? It's kind of restriction or condition. Okay? Otherwise, it can be too general. Computer is not that smart. It can understand only 0 or 1, and their combination should be organized, which means it has too many restriction. Okay, that restriction should be defined in our model. Okay? There are two types of model. It's very important to understand your project A also. First one is logical database model. In other words, there might be physical database model. Sometimes we call logical database model as high level model, which means there might be low level model. Okay. So what is a conceptual model? What is a physical or low level model? Conceptual model, simply this one, no computer. This one, yes, it has a computer. Okay. Conceptual model is, it can be anything. So I try to organize such a note taking, okay? So you can conceptually. So for example, red is the date because that is most important to search, and mostly there is a black. But if the Professor Lee made his voice is too loud, then it's a blue because maybe important, something like that. It has something, his concept. It's a high level, okay? So logical level. It can be applied to anything. Not only just a computer application, it can be applied to your daily life even. Okay? You can do many times, actually, do the conceptual model, high-level modeling in your life. Okay? When you design the senior project, when you design your programming project, you can do the conceptual model. And also, after that, physically, we need to implement such a model. So, for example, the model my life, then physically I try to implement. The important one is usually I'm going to use the red file and put all the stuff to the red file. And the blue one is the so-so, and the black is just nothing. Okay? So physically you put such a different color of the file. Similarly, so based on such a conceptual model, we can do the physical database data model, so physically implement. At that time, we need to consider something specific DBMS, database. Okay? Sometimes it's called low level, or sometimes internal level, it doesn't matter. Okay? So because of that, you may see, when you search the job, you may see something job description, like at least 3 years of the logical database model, or plus 3 years of physical database model. Okay, if you cannot understand even the job description, you cannot get a job. Okay, at that right now you can understand such a thing. There is another one, implementation database model, which is not general. Only this textbook mention about this one, so you don't have to worry about too much such an implementation. Okay. So, output of such a database model will be database schema. Okay, our goal is to find such a database schema. What is a schema? I think you heard about the name of a schema in other computer science subject also. What is a schema? Schema is kind of description. Okay, that describe when we are saying such a description, what describe is not narrative description, just like what I'm saying. It should be described by database structure, data structure. Okay, we will see anyway. Anyway, so schema means it's a description of the data. In other words, if you take a look at the schema, you should be able to understand what's going on inside, how this one is organized. So your goal is to define such a schema. Okay, database schema. For example, we discussed about our project 8 topic. So we try to implement the retail shop management system, our ticket reservation system for the MTA. Okay, then your goal is to find the database schema. Okay, at that time when you describe your ticket reservation system, not just a narrative description, but you should follow the data model, data structure that we are going to learn. We don't cover yet, but we will learn how to do that. Okay? Sometimes to represent such a schema, we prefer to use diagram. That's good news, right? So for example, you know what is a diagram? That is illustrated. So rectangle or the something, this one or the circle. This we will see such an example. That is this one. Can you understand what that means? Yes.
Yeah.
For example, this is something database student course. That means it may be university database, right? So it has something student course and prerequisite section, grade report. Even though we don't know exact details of it, but roughly everybody can understand. Each student may have the name, student number, class, and major information. So by taking, if you take a look at this information, you can understand what is a university database. So that is a reason it's called a schema, database schema. So database schema means it's a description of your database. That means throughout the semester, we will learn how to define such a database schema. If you can define such a database schema, then that's done. Then one more thing is, after we define such a database schema, that's it? No. Eventually, our goal is to manage the data. Okay? So for example, in the previous example, we have the university database. Then, after you have such a schema, anyway, we try to manage the bunch of student information. Okay? So we need to create such a real example, real data. If you consider that is called instance. Okay? Instance means it's a sample data, real data that follow the database schema. Okay? So for example, in this example, even though student has a bunch of different information, this student is usually sleeping in my course. That is the characteristic, that is, but that's not in our description. So we ignore, because when we define the data, data means meaningful information. Meaningful actually does not mean important. It's a very subjective. Meaningful means that we are interested to manage. So, for example, if I am very interested in the characteristic of the student, whether the student are very sleepy in the classroom or not, I probably put as another description. But this is not. So then, by following this, you can put, for example, name Lee, student number is 111, class is the DB, and major is the CS. This is called instance, one instance. So if you have such a schema plus instances, sometimes it's not only just one instance, it's many instances, many data. So that is at a certain moment you have the schema plus data. This is called database state. So this is our final goal, to create the database state. Okay. So database state is the content of the database at the moment. Okay. So database schema usually it can be changed, but not frequently changed, because it's a definition. It's our rule. It's the description. On the other hand, database state, the sample data, our data will be changed every time. students are in and out, if you graduate, probably your information will be eliminated from this table. So that is a characteristic. Sometimes we call the schema is intention, okay, and state is the extension. That's not a big problem, just the definition. Some of the textbook use this notation, but mostly schema and state. So this is an example of the database schema that we are interested to find. This is the example of the database state. As you can see, each schema has a sample data. Okay, that follow the format of schema. That is the different thing between information and data. Information is everything, right? The data is meaningful information. Meaningful means actually structured, or the formatted, or organized by following the schema. That is actually the one drawback, so limitation of the relational database. Because it's too much strict. What if I have the double major, like the CS and EE, which is not possible in relational database. So too strict. Okay? Nowadays, our data are not such a strict data. Sometimes our data is unstructured or semi-structured data, which is not available in the relational database. We will see more such a thing. Okay, so in order to implement the database system, we need to actually apply such a characteristic of the database that we discussed just before beginning of this class. Okay, so ANSI standard, American National Standard, whatever. So this is ANSI standard. They propose the 3 schema architecture that can actually reflect the characteristic of the database, which consists of 3 schema: external level, conceptual level, and internal level. All of the database, the system, they follow such a 3 schema architecture. First, conceptual level is, for example, employee or student. So, student consists of name, ID, and address, and major. For example, it's a conceptual level definition. I define my definition of the student is name, ID, address, and the major. This is a conceptual level, the schema. Conceptual level, the definition. Then, this student will be implemented in computer, right? So to be implemented in the computer, we need to find the file system, and under the file system, we need to create the file to keep the such information data. And in the file, we need to organize such a file by name, ID, address, and so on. Okay? So this will be implemented in internal schema level. Internal level. Okay. In practical implementation, who is in charge of such an internal level schema? It's the DBMS. This was the question in the last semester. 90% of the student wrong. Okay? So, student, when you design the database, that is conceptual level. Then you will create the database. Okay? When you create the database, that will be created in the computer system, internal level. That is an internal schema. You don't know details about such an internal schema. Okay? If you need to know, you don't have to use the DBMS system. So that is the reason we need such a DBMS system. DBMS system where you can just put, please create the table or the database structure for student with the name, ID, address, the major. That's it. And it will be created inside the data, the computer. It is very, very sophisticated and complex. Then, another characteristic of the using database is what? Do you remember that? Multi-view. Okay? Instead of one, I erase this one, foo.txt file can be viewed differently. Even though we have the one file, it can be viewed differently. So that can be implemented by external level, external view. After we create the one database object, from time to time I mention table, but you will understand why Professor Lee mentioned a lot of time the table. But even though you do not understand what is a table, don't worry. It's kind of just the database object. So after you create the student, it can be viewed as the student 1, student 2, student 3, differently. Okay, that is called external view. View is not real database object. It's just a virtual. Okay, it's a different view. Physically, it's just one, but it can be viewed differently. It can be implemented in the relational database model as a view. We will learn what is a view and how to use the view. Okay? That is the three-schema architecture. The benefit of such a three-schema architecture is it can implement another characteristic of the database. Abstraction, data abstraction. You don't have to worry about inside, okay? You can just create conceptual level schema. Then, please create the student with blah, blah, blah. Then automatically create inside. So, it's a program and data independent. It's independent. So it's the same thing. After you create the student, if you create the external view 1, okay, you can just let this guy know. You can access the external view student 1. Through student 1, this user can access this amount of information for the student. You don't have to recreate the student object. Then this one can access this amount of information, like this. So they are abstract. View and real schema are abstraction level. So independent. Problem, you need to communicate each other. Okay? Who is in charge of this one? DBMS will take care of such a the different level of the data. Okay. So that is called the logical data independence and physical data independence between the different layers. Okay. The physical data independence means so we have external level, conceptual level, internal level. This is the physical data independence. This level is called the logical data independence. Such an independence provides the convenience to use the data. Otherwise, if we do not have this one, what happens? We need to know everything. You need to know the file system. For example, using file system, you need to know the name of file and where data is located and how they are organized. In your program language, you should know everything. However, if you are using the database, especially three-schema architecture, then we don't have to worry because it's independent. What we need to know is just create the schema, then it will be created inside the internal. If I access the external view only, we don't have to worry about how to create the schema. Somebody will create and inform me. You can use the student 1 view. Okay. So when we talk about the database model means it's a group of concepts to describe your data. Okay? It's a model. It's a concept. Group of concepts. Another thing is operation. So operation, in terms of operation, the database model has mostly two different languages. Okay? Two different languages. One is data definition language. It's called DDL. Another one is data manipulation language, DML. Which means I design everything. I want to create my database. At the time, create. When you create, you can use data definition language. When you access the data, at the time you can use data manipulation language. Have you ever heard about the database language? What is the name of database language? It's a SQL, structured query language. Structured query language include both data definition language and data manipulation language. Okay? And also there are another, in addition to that, data control language. But it can be part of the data definition language, but it doesn't matter. So data control language means, for example,
select.
I create only one table for the student, then create a view. Okay? That doesn't mean I have several different student tables, right? Only one student database, but it can be viewed differently. I need to give the permission to this user. I need to give the permission to another user. So at that time, when you give the permission or revoke, cancel the permission, that can be done by data control language, which is called the DCL. So roughly 2 types of language, but sometimes 3. It's a data definition language, data manipulation language, and data control language. We will learn mostly data definition language and data manipulation language in our class. One of the characteristics of the data manipulation language is it's a non-procedural language. What does that mean? Procedural language and non-procedural language. What about the C language? C language is a procedural or non-procedural? Procedural. And Java? It's also procedural. That means procedural language has start and end. Okay? It has a procedure. On the other hand, non-procedural language, there is no start and end. Like the SQL. SQL is not procedural language. Instead, it is structured query language. This is the query language for only specific data structure, okay, which is a relational model. There is no such a if then else. There is no the while loop, for loop, something like that. That is the reason it's a very quick. You can access the data, however, it's not flexible. Think about without if then else, how can you implement the condition, which is very, very popular in any the programming requirement. So to address that one, the DBMS, Relational Database Management System, provide such a little bit procedural language part. So we will see such a thing a little bit more later. In addition to such a database language, it has a lot of the functional utilities, like the backup and recovery, and transaction control, the data export and import, and many others, monitoring and the sorting, which are not available in file system. Okay, So that is another characteristic, not major part. It's additional functionality. Okay, so are we going to cover this one? Some of them. Okay, but we are not going to discuss in practical way. Instead, the theoretical way we will discuss about this one. I forgot one more thing. One thing. In one of the database, self-describing feature. Another important characteristic of the database is self-describing feature. What does that mean, self-describing feature? Go back to our previous example to access the foo.txt. To access the data in this file, we need to know file name. Then open, and we need to know how many bytes are for name, and what is the delimiter, and what is the next byte. We need to know everything. Also, you need to define this is the name and this is the phone number, something like that. However, if we are using the database you can create conceptual level, and internally it will be created. Where do you store such a data, such a information? That is inside the database. Inside there is a database that manages all information about your database, including schema and condition, constraint, everything. That is called catalog database. So this is another important characteristic that differentiates from the file system. So you can use the catalog database to get all the information about your database itself. Okay. I missed it because I can see something information about that. Okay. This is our DBMS system. Okay. So we will cover not all of this, some of the important components, the later. Okay. The first half we will focus on how to design. Okay. How to design the database, conceptual level design and physical level design. At the time, we will use some of the data definition languages and data manipulation languages. Okay. Then, after we finish the first half, we will learn query compiler, query optimizer. DML is built the first half, and some other important like the concurrence control, backup and recovery, and so on. We will deal with such a component in the second half. Okay? Mostly they are theoretical, not practical. But first part definitely is a practical way. Okay.